Now this question is actually a lot more challenging than it looks, right? And the first challenge here is identifying that this is actually a product rule question. When you're differentiating this, it's the product rule you use. Okay, now product rule is used when you're differentiating two expressions that are being multiplied, and the two expressions in this case are x and sine of 1 over x. So that's the key. If you can identify that this is a product rule question, that's nearly half the battle here. There's your u, the x, there's your v. Okay, now next battle then, or the next challenge is, well, this isn't a challenge. Differentiating that is no problem, but differentiating this is a small bit of a problem. Okay, it's the next thing is identifying that it's to differentiate this is the chain rule that we're using. So what I like to do is just take it completely separately over here and treat it like nearly a separate question to try and differentiate this. But there's your chain rule, and you should probably know at this stage that the process to do the chain rule is you call that the angle, in this case 1 over x, we call that u. Now look what I did there, I changed it from 1 over x to x to the power of minus 1, which you'll see why in a second, and then you rewrite this y in terms of u, so that's just sine of u. Now the next challenge again, so challenge number 3 is how do you differentiate this? So usual rules, multiply by minus 1, reduce this by power to minus 2, but change this back then. We can't really work with this when it's a minus 2, so we changed it back to a positive by bringing it below the line. That's your rules of indices there coming in there. Right, now differentiating sine of u, just go straight to cos of u, there should be no problems there. And the chain rule then says that to get your value, then to get your derivative, you just multiply du dx by dy du. So that's that by that. Substitute back in then your value for u, so substitute this back in here. So that's where you get that. Okay, now that's the derivative of that. So that's actually your value for dv dx. Okay, so when you differentiate that, that's all the steps you must go to. Then you must go back and do the actual product rule, which should be no problem now at this stage. So u by dv dx by v by du dx. Make sure and simplify this carefully. Look, see the way the x here will cancel with one of these x's here. So that's as simple as you can make this. Don't be trying to interact this with this or anything like that. That's as simple as we can go. Now before we go on to B part 2, right, just have a quick reminder of what the actual main purpose of differentiation is. The main application of differentiation is finding tangents of a slope, right? So if I ask you to get this, find the slope of the tangent to the curve at the point A. So this is your function, okay? If I ask you to get the slope, what does it mean first of all? Well, right, there's your tangent. We want to get the slope of that, and like the main application, it should be screaming out at you that you get the derivative first of all, and you sub in your x value into the derivative. And when you get an answer of minus 15 in this case, and that tells you the slope of this tangent. Okay, now that's probably the first thing you learned when you were studying the applications of differentiation. So when it comes to a more complicated question like this, it doesn't matter that it's a lot more complicated. It's a more complicated function. There's something to do with radians in there, 4 over pi, that looks a bit more complicated, but you still stick to the same logic. Right? To find the slope of a tangent, you find the derivative of this, which we already have, and substitute in your x value. And that's all you need to do. Right, so find the derivative, substitute in your x value. So we have the derivative already. We substitute 4 over pi, and now you're just simplifying. Your calculator will do most of this for you. Now what you could do if you wanted to do some of it in your head, 1 over 4 over pi is the same as pi over 4. Right? You could then actually go to your log tables and find that cos of pi over 4 is 1 over root 2. Sine of pi over 4 coincidentally is also 1 over root 2. And when you simplify that out, then you get this. And it says to correct to 2 decimal places, so literally just type that into your calculator and you get 0.15. Okay, so it's actually a lot easier than it looks. This part 2 is anyway. I think the biggest challenge really is in the part A. Now, just watch out as well. If you decide not to use your log tables and you use your calculator instead for this part, that's perfectly fine. Just make sure your calculator is in radian mode.